So today we will be discussing about types of space missions actually. So there are many different types of space missions are there. Yesterday we actually discussed about orbits actually. Orbit means those orbits that are around Earth. Okay, just a second. Yeah. Give me a moment. Okay, so yesterday we discussed about what is called the space satellites. Okay. In that case, in the case of satellites, actually we discussed about satellites that are orbiting around Earth. Actually, okay. So they are actually Earth-bound missions or the orbit of Earth. Okay, so orbit of Earth is there. And when people go to space, something like the Yuri Gagarin went to space, he actually went to space and came back, something like this. And usually sometimes actually they make some 1 or 2 orbit and come back. So we are actually not discussing generally about the Earth-based orbits because that we already discussed yesterday. Okay, but these space missions are more about other planets in the sense it includes planet and moon. Okay, so those kind of missions, that is what we are actually discussing here. What are the different types of them? Okay, if you go for generally space missions that actually include the earthbound orbits and earth orbiting satellites, even the sounding rockets, some balloon experiment, everything actually included in the maybe in the space mission. But we are confining to the space mission that is for other than the outer space. Okay. So that when you go for other planets or other celestial objects, then those kind of space missions are classified here. And let me briefly go through those classification or what type. So the first one is called the flyby missions. So this is called the flyby mission. And the second one is orbiting. So flyby is simply, I will explain each of them one by one. Flyby means it will go near, that's all. Okay. Then another one is called the orbiter. As the name suggests, here there is something called a orbit is there. So it will make orbiter. So that is, so it will keep on orbiting around that. Something like a satellite for Earth. So suppose moon, around the moon there will be an orbit. Okay. So that is orbiter. Then there is sorry, I forgot to include another one, but it is discussed there. Okay. There is something called a lander is there. So you know that what is a lander. So orbiter will be there, but apart from that, there will be a something that will go and land on the surface of the moon or planet. That is called the lander. Then there is something called a rover is there. Rover is kind of a vehicle, a wheeled vehicle. That means something like a robotic car, which is able to move through the surface of the whichever planet that you are observing. So that is called the rover. Then there is something else called a sample return missions are there. Sample return means, and again a robotics system will go. Okay. And before that, there is something called an impactor is there. Impactor means it will, so for a lander, that lander consists of many instruments and all. So that lander has to be landed on the surface of the planet softly. So it should be a soft landing. Why it should be a soft landing? Otherwise, the entire instrument will be malfunction because of that shock when it falls. It will be crashed actually. But in the case of impactor, we are actually not going for a soft landing. We are actually going for something called crash landing or a hard landing. Okay, so hard landing will be happening. It is something like throwing a stone to the surface of a planet, or it is suddenly something is falling, and it can actually, during that course of movement towards the surface, it can actually measure many things. That is called the impact probes or impactors. So impactors or impact probes. Then sample landers are there, and along with that, sometimes they can have sample returns. That means it can actually collect samples from the surface. Something like the Perseverance is actually doing that right now, but it is anyway not returning. So it can collect sample from the something like the rock, maybe even what is atmospheric dust, or we have actually done it with the even with the comets and all. So those kind of sample returns. So a robotic arm or a robotic system will collect the sample and it can return. I'm not talking about the sample return that happens during a human space flight. This is completely robotic actually. It's completely robotic. And another one is the helicopter or rotorcraft. So something like a simple a flying thing will be along with it. So we have a car-like thing that is rover. Other than that, a helicopter-like thing or a rotorcraft can be there, and that is the another helicopter. Then, as you know, there is something called human space flight, where the real, okay, other than robots, the real man, human being can go there. So that is the human space flight. So let's check one by one. So flyby spacecraft. Okay, so here before reading all these things, you can see here, this is basically the flyby. Okay, I will show you one more thing. Here, see this, this is, assume that this is a planet, okay, and you can see here, it comes and go like this, okay. So it is not orbiting, it is actually going nearby, that's all. Okay? It is actually flying nearby, that's all. Other than it is not orbiting or anything. It comes here, and when it comes here, during that movement, when it comes for the close encounter, during that close encounter, it can take the photos. Close photos can be taken, high resolution photos can be taken, and that is called the flyby mission simply. Okay. So let's see, it is actually a conduct of initial data collection of the solar system. So two purposes. One is the initial data collection. Initial data collection in the sense that actually, if you are trying to explore one planet or maybe the moon, it is actually difficult to have an orbiter or a lander at first. Okay, because to study about that particular planet, it is better to have an easy mission. That easiest type of mission is actually the flyby. Okay, so there is no, it just go near to that and take some photograph or analyze the atmosphere. If it is that close by, then go away. That's all. Okay. So other than that, it cannot actually. There is no need of an orbiter, so that for orbiter actually it has to slow down, and lander is a bit more complicated. So this is a simple system. And this is not only used for data collection, sometimes it is actually used for something called gravity assist. Gravity assist or maybe slingshot, you may know. Okay, so so the gravity assist is something like when it pass by, actually it can. Okay, so suppose that this is Jupiter, and this is my spacecraft actually going towards maybe to Uranus or Neptune. Now the Jupiter is there in between, suppose. So anyway, for this long journey, I need fuel actually, because it is going outside the solar system, or maybe to the Uranus or Neptune. I need to carry more and more fuel. So it is so difficult. But instead of carrying more fuel, actually I can use the gravity. Okay, if I put that, if I allow that satellite to orbit in such a way that it can go near something like a flyby, and when it attracts, it is actually kind of a slingshotting. So it attracts and it increases its speed. Okay, it comes here. So assume that here the speed is some 10, then after this it becomes maybe some 50 or 60. That kind of change will be there because of the gravity assist. That depends on, if it is a Jupiter-like planet, the gravity assist will be so strong. Okay. So the best example is actually the Voyager mission. Already you know that it is even beyond the solar system. Now it is actually entered into the interstellar space or something like beyond the heliosphere right now. And it actually, how it got that much energy to go there, it is not from the proper rocket fuel. Actually, it used the assist of Jupiter and Saturn actually. So using those gravity assist, it were able to go that distance. Okay, so that is another purpose. And it is usually follows a continuous solar orbit or escape trajectory, not captured into the planet. Okay, so planetary orbit cannot actually capture it because it is that fast. And equipped with the instruments to observe target during close approach. When it is close by, it can actually take photos. And one of the important thing regarding the Voyager mission is that the many of the new knowledge, actually the concepts about the planets and planetary atmosphere and surface, entirely changed after the Voyager 1 and 2 mission. So it was able to capture the close by photos of many things actually, even Titan, Europa, and many other satellites as well. So, and especially we got to know about the range systems of the planet and many things. Okay, then it, as usual, it has the ability to get data, and that data will be sent back, and okay, that will happen. That is anyway we need, otherwise that is actually useless. Now in flyby, we can actually classify it as a far encounter phase, so three phases are there. One is observatory phase. Observatory phase means, so suppose my spacecraft has a camera, and when this camera can take a picture of that planet, for example, Mars, that satellite can take a picture of Mars, and that photo of or that picture of that Mars is, if it is better than that of the Earth-based instrument, because Earth-based, I can actually use many instruments to observe Mars. But if my picture is better than that, then I can say that my flyby mission entered the observatory space. Now there is something called the far encounter phase, when the full disk of the planet can no longer fit in the field of view. That means when you are far away with a camera, so you can actually completely see the planet inside that frame. Actually, okay. So something like, assume that you are picturing an elephant. So when you are far away, actually you can get the entire elephant. So once you are close by, okay, you can say that you no longer get the entire elephant, like the entire planet is no longer visible. You can see only a part, that is called the far encounter. Okay, then the closest approach is called the near encounter phase, and during which also it can take photos. Here you can see this is Ganymede, that is the satellite of Jupiter, and you can see some part photos actually. And the problem is that flyby is not something like the orbit. Okay, so when it is orbiting, actually the advantage is that that satellite can completely map the picture or map the surface. But here the problem is that it cannot completely map, because it is a short time, and within that time, whatever it is possible, they will take the picture. It will take the picture and it will be mosaic or something like this. That is why some part is actually missing. So this is what we got, and this is stitched together, and we got that picture. Okay, so that is called the flyby mission. So two of the main, one or two, yeah. This is the Luna 1, that is the Soviet space program. This is the first lunar flyby. Okay, this is the first satellite to fly by another object, another celestial object other than Earth. That is the Luna 1, and it is also called Mecha. Maybe Meta, I don't know how to pronounce it, is in Russian, and the meaning is dream actually. Then first spacecraft to reach the vicinity of Earth's moon, and spacecraft to leave the Earth orbit, and spacecraft to be placed in the heliocentric orbit. It was in 1959. And another one, this is about the lunar. So this is the first one to orbit a satellite, or maybe the moon actually. And Mariner 2 is actually the first spacecraft to fly by another planet actually. Okay, so it actually not the moon. It is the first one to fly by another what is called the planet. Okay. So it was to Venus actually. So this is a Venus flyby mission. So we can call it as a first Venus flyby mission, or first planet flyby. So that is by NASA in 1962. Okay. So when you now onwards, when you see the spacecraft names, or maybe the spacecraft, just note down which country it is. It is actually Soviet space program, means by the USSR, and NASA means USA, you know that. So these two things are there. And see, this is in 1959, 1962. So sometimes you see that the same type of mission happens in the same year actually. So this is where something important is happening in the history of space, or history of in the history. That is something called the space war actually. So some space war were happening during the Cold War. We will discuss about that tomorrow anyway in detail, because that is so important in the history of space exploration. So this is another, that is the flyby spacecraft example. The best one is actually the Voyager program. So see, Voyager actually flyby many things, something like the Jupiter, Saturn, then Voyager 2, Jupiter, Saturn, Uranus, and Neptune. And also it actually discovered the moons as well. Also they observe the take good photos of the moon. So you can see the discoveries. So this is why I said that this is one of the most prestigious mission, maybe we can, or and still, you know, that it's still active actually. It's still, we have contact with. Sometimes some issues which happen during, I think, the end of 2024 or something, but it's now, even now we have access to that. See, so this is the discovered the volcanic activity of Io and great for detailed image, then Titan's thick atmosphere, then uh, observe Ganymede, Europa, Jupiter's magnetosphere, explore Saturn moons and rings, studied the atmosphere. So many things. So that many things actually it was able to study. That is a Voyager program. You should read it about this in detail. So it is that interesting. Now the second one, bit more complicated, but anyway, anyway, Voyager 1 or Voyager 2 are not a flyby mission exactly. It is actually an interstellar mission. So it is going far away from the solar system to the outer space, maybe even out of the solar system. So, but during that mission, it can actually get data from Jupiter, Saturn, Uranus, Neptune by using the flyby. And at the same time, there is another good thing, that is it can actually get the gravitational energy, or maybe it can actually speed up using the gravity assist. So the next is orbiter spacecraft. Here you can see the animation where if it was a flyby, it would have been gone something like this. But here you can see that it comes here and starts to orbit. So how a flyby mission can be changed to orbiter. Yesterday we mentioned that there is something called escape velocities. So that is the minimum velocity that you need to escape the gravity of something. Earth has an escape velocity, Moon has, Mars has, any planet, anything has an escape velocity. Now here what happens, when it comes near, if its velocity is more than the escape velocity at that point, it will actually go like a flyby mission. Now, if we are able to slow down when it comes here, okay, so for that, some reverse firing will happen. So that means, assume that the satellite is coming in this direction, it is on the way, and this is the back side and this is the front side. So it looks like a rocket, but anyway, just assume that this is the engine. So exhaust is. So if I fire this engine, what will happen? Its speed will increase. So that is not what we need. So when it comes to the close encounter, I needed to slow down so that the planet will automatically capture that satellite, that spacecraft as its own satellite. So that is what's happening. For that, what they do is that they will actually turn the satellites, something like, so if this is, now they will actually turn it something like this. See, now this is the front and this is the back. Okay. Now if they fire the engine, what will happen? It is actually against the direction of motion. So, or it is against the usual direction. Now it will slow down. So once it slows down and becomes less than the escape velocity, this thing can actually capture, this planet can actually capture it, and it will make orbits around that, and that is called the orbiter spacecraft. So it is not that easy thing, but it is actually not many space agencies are able to do this anyway, maybe 6 or 7. So this is also again, so then it can actually orbit, and it needs its own battery and all these things. That's similar to that of a satellite, and it has to communicate with the Earth. Okay, so but an advantage is that it can actually study the surface entirely, just like a satellite. How a satellite actually observe the Earth's surface, like that, it can actually take a lot of photos. Maybe it can analyze the magnetic field and so many things. Okay, so that is about the orbiter spacecraft, and this is another example you can see. So this is the launch speed, and this comes here, and when it comes here, actually it is reverse fire, and then it can actually orbit. This is one example. You can see it goes from here, from the Earth, and comes to the Mars. So okay, so this is launching, that dotted line you can see. So it comes and orbits. So this is how it actually happens. So this is just an example of one planet. Okay. Now another orbiter spacecraft example is the Luna 10. Okay, so here you can see the first artificial satellite of the Moon. Okay, so this is the first artificial satellite of the Moon, and any other body other than Earth. So it is the first artificial satellite and any other body other than Earth. We had Sputnik 1 is the first orbiter, or maybe the first artificial satellite around Earth. But first artificial satellite other than Earth is actually Luna 10, and it launched in 1966 March 31 by USSR, that is by the Soviet space program. And just see, just after not even a year, some just March, April, May, June, July, August, okay, within some 4 months NASA also did the same. Okay, so lunar orbiter, that is the name, that is the Orbiter 1, 1966, August 10, NASA. So the first American spacecraft to orbit the moon. But they got the second anyway. But see how tightly they are actually keeping up with that match, actually, how that race is going on. So that you can actually see from this history. Even without learning the history, we may think that even if you don't know about the space war or anything, we may think that, oh, this happened. So when I read about it initially, this we can see that if you just check the year, you will see that both happened in the same year. Then we check that which is first. Then you will see both happen just for just 4 months apart. So that how the space race went on. Okay, now another one, the orbiter spacecrafts. Two examples, only two examples. There are plenty of orbiter examples out there, but I have included only two of them. That's all. Okay, so that is, one is Mariner 9, first spacecraft to orbit another planet. Okay, so Mariner 9 is actually the first spacecraft to orbit another planet. This is planet, not moon. Okay, that is Mars. So that is Mariner 9. And there is another mission called Cassini-Huygens. So Cassini-Huygens is a mission by European, that is NASA, basically USA, then Italy and European Space Agency. So this is a combined mission, and it is actually orbited 13 years studying its rings, atmosphere, and dozens of moons, actually. So and it actually it delivered the Huygens probe, and it had an Huygens probe which actually probed to Titan, unveiling the lakes of methane. And actually that Cassini was actually planned to impact, or just to land, not to land, to crash land on Titan. Then they realized that when there is a lakes of methane, there might be a chance of some kind of life form. So it is not good that to crash land something to a moon where we are expecting maybe some kind of life is there. So it is not good to land it is there, or maybe to crash land there. So then they plunged that mission to Saturn's atmosphere, actually. The second, so this is about the orbiter. The another one is actually impactor. Okay, so impactor is basically some kind of a solid thing, something that consists of all the mechanical, maybe some instruments will be there. So one way it happens is actually either the satellite can directly go and impact something, or another way, like here. Okay, this is not a real picture anyway. Something like you have a satellite, so that satellite keeps on orbiting the moon, for example. Okay, now from that we can drop something. Okay, it is something like dropping a stone from a flight. Okay, anyway, it's not like the flight, just giving a terrible example. Okay, so anyway, from a satellite, if you throw something, or if you put if you are able to drop something, then that is actually that will actually it will comes like this and land. But the problem is that if you doesn't have the technology to soft land, then it will land something like a crash landing. But even during that crash landing, it is moving through the atmosphere, so it can actually measure something regarding the atmosphere. And there is one more thing, when it hits, okay, so just imagine that a big rock is actually thrown to the surface of maybe some sand or something, then some sand will actually eject out of it. So those ejecting sand can be studied with the help of the orbiting satellite. So that is also the thing. So this is the one example. Deep Impact was a NASA space probe launched from okay, that you know that it was designed to study the interior composition of the comet Tempel 1. Okay, by releasing an impactor into the comet. So this satellite, this Deep Impact, this mission actually consists of a satellite and an impactor. So that impactor go and hit the comet, so that it will we can get to know about what is more inside that. Okay, so that is about the impactor type of props. Okay, so the problem is that it's gone forever. You cannot actually recover it. So once it is crash landed, usually those electronics or anything, it will work till it hits the ground. Okay, so suppose this is the ground and it will come like this, and just before hitting the ground, it can actually send data to the orbiter, but other than that, it won't work actually. So that is how it works. Okay. Now, one or two example, Luna 2. So this is Luna 2 is the first human-made object to impact the moon. Again, see that is from the USSR, Soviet space program. So if you check the history, you can see that till the first man to moon, everything actually won by USSR, and that is why USA or the NASA was actually needed to have USA needed to win this by landing man on moon. Okay, so that much prestigious was that mission for them. Okay, so then another one, this deep impact. Deep impact sent a projectile into the comet Temple 1 to study the interior. Impact released material that was analyzed by the flyby spacecraft. It provided key data on the composition of comet and the early solar system. So this is called the impactor examples. Okay. Now let's see the next one. So I am actually, this is in the order of difficulty. You can see. So it is easy to have a flyby. Orbiter is a bit more difficult. From the orbiter, and impactor is a bit more difficult. Now we are going for a lander. So lander is one of the most difficult. Now I am not saying the most difficult, maybe kind of. If you have the lander, then actually you can even take the man to the planet. But anyway, that needs different ecosystem, and you can even take a car inside that so that you get the rover. But landing is so important. Okay, so it is something like the rover will be there, and that lander go and touch down on the surface. So when it goes and touch down, so that name is even called a touchdown, or we call it as soft landing. So it should land softly, maybe with some leg with the proper shock absorber and all. So it has to go and land slowly. Okay. So one thing we may think, the similar thing we actually do when the space capsule come back, but what we do, one thing is by using the parachutes, and another thing we actually land to the sea so that the impact will be less. Okay. So anyway, the problem is that when it comes or land like that, if there is no atmosphere at all, okay, something like if the atmosphere is so thin like that of moon, then we cannot actually use what is called the usual landing techniques, or something like the parachute cannot be used, especially in the moon. We cannot use that. So what they do is that when it comes closer, I will show you some more videos of that. Okay, so assume that this is my spacecraft, something like this. It is coming down, then I will fire some rockets. Okay, rockets in the sense that I will burn my engine. So this is my engine exhaust. So it will be burned in this direction. So when it burned in direction, what will happen? It will slow down, slow down, slow down, slow down. So there will be at least 4 of them will be there, so that everything should be properly burned. So even if it comes and slowly lands something like this, okay, it flip over, then even maybe it becomes useless. Okay, so it has to be properly calibrated and balanced so that it can land on the surface of whichever planet you are intending. Okay, so that is how a lander works. Okay, so this lander can actually usually send data to the orbiter, and that orbiter will send data to Earth. So that is how the data. So there are many mechanisms used to land spacecraft. One is actually parachute plus airbags. Okay, so it is used in Mars Pathfinder Spirit Opportunity, and it is actually used some. So see that it is used in Mars only. It cannot be used in Moon, because Moon have a very thin atmosphere when compared with that of Mars actually. So we cannot. It's pointless to use a what's called a parachute. So it comes on a parachute, then slowly descend, then finally it fell off. But when it fell off, just before falling, it will have a kind of an airbag actually. So something like the airbag that we use in car, some kind of a balloon will come around that, and using that balloon, it will land softly and it will roll, and something like it's simple. Okay, but it happens only for payloads, lighter payloads. Then another one is actually used for Curiosity and Perseverance. That is another from NASA. That is the sky crane. Actually, it's better to. I will show you some videos that would be better than this actually. Then power descent. That is the retro rocket. Okay, it is not that complicated as the sky crane or this is what I mentioned, that the retro rockets or powered descent, it will thruster will slow down the spacecraft descent slowly and slowly, then it will land. Okay. So, but it needs some precise control and stable terrain. Okay. We cannot land it anywhere. Okay. So, stable terrain is also needed. So, I will show you one video. So, this is the Perseverance. I think this is about the sky crane actually. So, this is not a real video anyway, animated. This is how it works actually. Okay. So, this is what going to land. See, since Mars has a, even though it has a thin atmosphere, actually it gets heated up. So this is the parachute. So you can see here, this is it. It's going down. One way is that we can actually land using this technique, but instead of that, now, yeah, this is the sky crane technique. So this is what actually going down. See this? And those rockets are called the retro rockets. It will slow down. Now you can see behind that some wheels are there. That is actually the Perseverance. So now you can see that. So this is called the, you see, so those wires, yeah, this is how it lands. And it will go and land somewhere, crash land somewhere. Now this is there. This is how the sky crane works. Okay. Now this is the second thing that I mentioned, that is the balloon technique used for Spirit, Pathfinder, etc. This also, the initial space is almost the same. You can see that with the big parachute. And yeah. So this is the system, and when it, yeah, see, this is the airbag. When it reaches near, the airbag will be deployed. And this is also retro rockets, again slowing down. See, it will bounce like this, especially since the gravity is low, it will bounce more than that of Earth. But since it is inside that those airbag, it will be it should be safe. See how beautiful the technologies. Yeah. And this Pathfinder, actually, you can see a screenshot of that in the Martian movie, actually. That's okay. You can see the video later. Anyway, this video will be there in the YouTube or will be there in the slide as well. So that is about the, then another one or two are there, but it is not widely used right now. That is the legged design platforms. Okay. So spacecraft descend vertically and land on shock absorbing legs. Okay. But the problem is that it is quite difficult. Okay. Not that reliable actually. But anyway, if it is a very good terrain, something like a flat terrain and all, then it can actually land. Okay. Then touch and go is something like the spacecraft briefly touches the surface to collect a sample, then ascend again. So it is something like it just land. Actually, the spacecraft will come, and if it needs some data or something, it will collect the data and then go back. It is actually not landing or staying there. Okay, so that is called the touch and go or tag maneuvers. Okay. So this is about the different mechanisms of orbit. Some lander examples. So Luna 9, you can see that is the Luna 9 achieved the first successful soft landing on the moon. It transmitted panoramic image. So this is the first photo. Okay, see, first photo ever taken from the surface of another celestial body. Okay. So this is taken from the surface of moon. Okay, so that is the Luna 9, and InSight is another in 2018. InSight landed on Mars to study the interior using a seismometer and heat probe, etc. That is also another lander. There are many actually. I'm just giving you one or two examples. So the next is rover. Okay, rover already you might be know you. That is something like rover is simply a car, which is actually a robotic car which is able to travel through the surface of any whichever planet it is, okay, or maybe moon or planet, okay. So can travel across varied terrain to explore different location, able to reach features like rock, craters, and hills, and are beyond reach of stationary lander. So lander is fixed, okay, so it cannot go more than that. It may take some sample by using some robotic arms, or maybe it can study, but it doesn't have a mobility. Okay, something like you have to sit somewhere. So once you get the car with you, then you can actually move along. So scientific equipments will be there, then cameras will be there and along. Okay, so that's about the rover. Okay, then rover example, this is the Sojourner, or part of the, this is the name, Sojourner is the name of the this vehicle or the rover, and it is actually part of the Mars Pathfinder mission. Okay, and launch date in December 4, 1996 was the first successful rover on Mars. Okay, this is the first successful rover on Mars. And Shurong, this is some Chinese pronunciation, it is by China, CNSA, Chinese National Space Agency, July 23, and it's the China's first Mars rover. Okay, so it is a part of the Tianwen-1 mission. So here, this is their rover actually. It looks like a bird kind of. Okay. Yeah, that's it. So that wings are actually the solar panel. Then another main example that is still it's there, that is a Perseverance rover in March 2020 mission. That is a mission name and launch date on 2020 30, and this is actually, you can see this is animated movie, two pictures are there, and this is actually a selfie. Okay, you can see, if you see here, you can see a robotic arm is there, and it consists of a camera. It is actually that selfie taken by the vehicle itself. Okay. So Perseverance, also called Percy, is the NASA's most advanced Mars rover to date. It landed in Jezero crater, and because believed to have hosted ancient river delta or lake, something like that. That's why it want to reach there. And there is one more thing. You can actually see those videos and all in YouTube. Actually, one of its standout feature is that the sample catching system. So it consists of a kind of a drill bits. Many types of drill bits are there, and these drill bits will actually drill. And when you drill something, you will get some mud or anything out of it, and those samples will be collected into test tubes, kind of a test tube, not a usual test tube anyway, that kind of a sealed tubes, and it is actually kept in the inside that rover actually. It's there actually. And if after that, maybe in future, when there is a sample return mission, that mission will go and reach to the rover and get back the samples and come back. Okay, just imagine how interesting that is. Then Perseverance is also carried the Ingenuity, okay, the Ingenuity helicopter, okay, which become the first powered flight on another planet. Okay, so that is the helicopter or rotorcraft spacecraft. This is only one, the one and only, that is the Ingenuity. Okay, Ingenuity, you can see it actually, okay, originally designed for just 5 flights, and it completed over 70 flights already. Okay, so that much. So, but it is not that easy, because to fly something, you already know that air is necessary. Without air, you cannot fly anything. So that is why we use rocket in space. So similarly, for this helicopter, it is actually difficult to have fly, so it need powerful blades or powerful rotors, and also it should be lightweight. Okay, so you can see it's something like a small one. And actually, one more actually NASA is planning in future mission, and it's the name is actually Dragonfly or something. So that's it. It is equipped and it can actually help to scout for that perseverance. So perseverance is here. So something like it helps to move. So suppose that perseverance is here, it can actually help in scouting. Something like the this ingenuity can move to somewhere over here and check that whether that place is safe and smooth for the travel of our perseverance. Then uh, that is one advantage. So that is how it also works. It helps actually our this what is called a perseverance, that mission. Helicopter example. Oh, sorry. This is again. This is the just the brief of that. That's the only one. Okay. So it completed 50 flights and it served as a scout for the perseverance. Okay. So this is the video. This is not an animation. This is the real video. The real video footage taken by the perseverance. Okay. So here, this is here, just see. Yeah, it started to rotate. Yeah, see this. So just imagine, so when you see this video and all, we may feel that it is so simple. Okay, the technology might be simple, but it is not at all like that. To land there, to move there, and to have a helicopter there. So the engineering is something marvelous. Okay. That is why I said that everybody in the field of any field of science has opportunity in space actually. So I'm not specifying about any particular space agency, but whatever space agency is there. So for example, this need mechanical engineers are needed, and electronic engineers are needed. Then software programmers are needed. So computer engineers are needed. So any kind of thing are needed there. So that is the importance of this. Okay. And you might heard a news that we may a biomarker of life is actually detected in a exoplanet actually. And yesterday or today morning or that news came, and that is actually connected to astrobiology. So biologist even has a role in studying astronomy or space science. So this is another thing that is called the sample return spacecraft. Okay. So it will go there and collect the samples. Okay. So sample return happens even with the manned missions because it is very easy to collect for a man. But other than that, some robotic arms will go there and collect the soil, rock, maybe sometimes even dust or even gas will be collected. So in the case of, if you remember the Rosetta mission, Rosetta and Philae, I forgot. Yeah, yes, exactly, Rosetta and Philae. And in that, actually, they used a kind of a net actually. So Rosetta and Philae was a mission that to land on a, not to land on a, it's not to land. Yeah, it's actually to land on a comet called Churium of Carese Mango, something like that, some Japanese name actually. And it had actually a kind of a net. That net is able to collect the material from the that comet actually. So when comet heats up, there will be a lot of ejecta. So that ejecta is being actually got to collect with the some kind of a net that we use for so a small kind of a mesh actually they had. Okay, so there are some beautiful animations as well in European Space Agency as well. It was a project by ESA actually. Okay, so that is a then sometimes it can actually return the sample that is called the sample return spacecraft. One example is the Luna 16. So again, it was the first robotic mission to return lunar soil to Earth, again by USSR Soviet space program. Okay. It collected 101 grams of samples and proved automated sample return was possible. So then another one, Osiris Rex, is there, and it is collected the samples from an asteroid Bennu and returned them to Earth in 2023. I hope you remember the news that came during that time. Okay, so that is another one. So the first one is the something to return from a from moon, and this is from a asteroid. Okay, so that is a sample return examples. Now the last one, human space flight or the crewed missions. Usually we call it as crewed mission, or okay, that's another name, or human space flight. Okay. So in this case, human space flight, usually we use this name not just for the planetary missions or maybe the mission to moon. Anyway, we only reached to moon, that's all. We haven't went to Mars or any other planets yet. Anyway, we went to moon, but even other missions, like if you go to space, to the International Space Station, that is also called crewed mission. So if that spacecraft, whatever spacecraft that goes to space, if there is a human being, then that is called a human space flight or a crewed mission. Okay, so main advantage is that instead of taking a robot, it is actually every time it is better to have a human there. Okay, so that much intelligence nobody has ever. Okay, so that is the importance of this, but the main problem is it is so risky. So it need many different modules, and it need the must ensure life support system, oxygen, water, food, waste management, everything is needed, and radiation protection is needed, and temperature control, pressure control, all those things should be there. So it is so risky mission to have human in the spacecraft. Okay, and safety systems should be there. If something happens to the rocket, there will be some launch escape system, then emergency re-entry systems will be there, and require specialized habitat, sleeping quarters, and communication system. So communication system in the sense, if you go for a spacewalk or something, then they have to communicate each other, so that is also needed. Then mission components, crew module. So this is usually the two crew, that is when that spacecraft is alone is there are some main components will be there. One is called the crew module. So when you go and read more about the Apollo 11 things, you can actually see this name, crew module, service module, and all. Crew module is the where astronaut live and work. Okay, then there is something called the service module, provides propulsion, power, and life support. Okay, so these are two parts of that, and can actually read more about that, or just go and watch the movie Apollo 13. You will understand it's much better than that. So then powerful rockets is needed to lift the crew into space. Why we need powerful rocket? Because all this life support system, oxygen, water, food, and everything has to be taken in the same spacecraft. Actually, they have to take the powerful rockets, because the heavier the spacecraft, then heavier the launch vehicle should be that powerful as well. And it obviously it always need the landing system. So if it is an orbiter, or maybe unless it is a sample return, actually you can leave that spacecraft wherever. Oh, it's okay, no problem at all. Okay, so it's something like we haven't returned any of the unmanned mission other than the space sample return mission to back. Okay, but in the case of human space flight, we have to take them back. So it need retro thrusters, parachutes, and soft earth return systems and all. Okay, so types of crewed missions here. One is orbital missions, something like the stays in orbit, example International Space Station, or even in the case of space shuttles where that is also go in orbit, and that repair mission of Hubble and all happen like that. Then lunar mission, travel to and land on the moon, example Apollo mission, that is the only mission we had to moon. And there is an upcoming mission by return to moon, that is called the Artemis mission actually. That is actually coming soon. And the future Mars mission planned for 2030, okay, may happen. Maybe, I don't think in 2030. It may take some more years, but anyway. So future Mars missions are also planned. So crude example, the best first example to go to space, it's actually Vostok 1, in that is the mission name, and you know that person in that person there, that is Yuri Gagarin, first human in space. Okay, and he orbited almost 108 minutes in orbital flight and made Gagarin an international hero. Obviously, just imagine that. Even if imagine that nowadays, if even maybe you are not the first or second or the 10th, maybe 100th man to go to space, then you will be a celebrity for sure. So that is the second one, that is the Apollo 11, its importance. That is that landed men walk on the moon. This is from the New York Times, that next day of moon landing, Apollo 11 was the first mission to land humans on the moon. Neil Armstrong and Buzz Aldrin explored the lunar surface at the same time in the service module, and he was there in the module, that is Michael Collins. Okay. So yeah, a small step for a man and a giant leap for mankind. So these are all some brief, first of all, okay, which happened first. Okay, you can see here, this is first mission to moon. Okay, this is specifically for moon, not about any other. Okay, it's about moon. You can see first flyby, Luna 1, first orbiter, Luna 10, Luna 2, Luna 9 lander, and all you see, this is USSR, and even the sample return. And the crewed mission, actually, NASA nailed it, and they were the first in 1969. So it was the first to land on moon. Okay, so this is a brief to see the first. And these are the first mission to other planets by spacecraft type. Okay, so first flyby Mariner 2, first orbiter Mariner 9. So what happened is that after Apollo 11 or something like space war was almost came to a plateau, and there is not much. Okay, but anyway, till 1970 you can see Russia is still there, but after 1992 or something, USSR collapsed, and so they actually not that performing good after that. Then we have the Russia's Roscosmos and all, but anyway, Lanter, you can see, then rover is there. So okay, this may not be correct. I think this is, I have to check, this is not correct. Okay, this is China's first, not the world's first. Okay, I will correct it and give you the proper slides. Wait. Okay, then helicopter photograph, Ingenuity, sample return, Osiris. Okay, then crewed mission to any other planet, none yet. Okay, maybe you might feel it later. Maybe when you become sage of me, surely you will actually fill all the last line. So that is for you. So that's about today.